Hello everyone, welcome back to the channel. I hope you guys are doing really great. So let's see today's daily challenge on Leetcode and we will try to solve it together. And in today's video, I will show you two approaches to solve the problem. Both will take an n log n time and both will be accepted. So, but yeah, one will be greedy and another is binary search. So let's see the problem statement at first. And maximum running time of n computers. You have n computers with you. You are given the integer n and zero index integer array batteries, where ith battery can run a computer for battery I minutes. Okay, and you are interested in running all the n computers simultaneously. Initially, you can insert at most one battery into your computer. After that, at any integer moment, you can remove a battery from a computer and insert another battery any number of times. The inserted battery can be a totally new battery or a battery from another computer. You may assume that removing and inserting processes take no time. Note that the battery cannot be recharged and return the maximum number of minutes you can run. You can run all the n computers simultaneously. Okay, so you want to run all the n computers simultaneously. So if you try to see the first example, n equals to 2, so you want to run two computers which is there in front of you, and you have three batteries with you. First battery has a charge of 3 units, second has 3, third has a 3. Okay, so what if you connect the first battery to the first computer and the second battery to the second computer and keep running them for 3 minutes non-stop, right? So both of the battery will be drained after 3 minutes and you will be remaining with something like this 0 0. Two batteries are drained which are used and the last battery is remaining. Now with one battery, of course you cannot put one battery into two computers, so that will be your answer 3. But somehow can you obtain anything larger than this? You see, by redistribution you can always obtain something which is optimal, right? So let's say you can do something like use two batteries for 2 minutes, right? So after using two batteries for 2 minutes, what is the remaining thing? It is 1 1 3, right? These two batteries has been used for 2 minutes each, and you have been using it for 2 minutes for running both of these computers. Okay, and you try to see that now what you can do, you can connect this new battery to one computer for 3 minutes. Okay, and you can one by one replace this battery. So let's say battery 1 you use for 1 minute. Okay, after this what happens? This reduces to 0, this is unused, and this 3 reduces to 2. Now again you can see you can use this battery, the remaining battery which is, and after 1 minute of time it will give you something like 0 0 and 1. Okay, this thing you cannot use, but you see how many, you need to run all the computers simultaneously, and in this whole process you are able to run for 2 plus 1 plus 1 minutes, total of 4 minutes. How much time were you able to run earlier? You were able to run for 3 minutes, right? So this is more optimal, so you will have to return this as your answer. And if you try to see that, it is always possible that I will rearrange the batteries and use it for the optimal time. Okay, and yeah, but yeah, the way of using does matter, and yeah, we need to see that how much maximum time can we put it. Okay, so you see, first of all, by looking at the problem, you might think that when you are thinking, see, when you are thinking of how to approach what is the idea, you see that there is some kind of monotonicity over here. Okay, what do I mean by monotonicity? So if a battery, see, you need to find the largest such time t, okay, for which the battery will run. Now if a battery runs for t minutes, okay, so for t time, if you are able to uh, for t time, if you are able to run all the computers simultaneously, okay, you can say that if I am able to run all the computers simultaneously for t time, for definitely for t minus 1 time I can run all the computers simultaneously. Okay, now what I'm doing all this, you see, if you tell me that for t minutes you were not able to run all the computers simultaneously, then you can also tell that for t plus 1 minutes you will definitely be not able to run the computer simultaneously. So there is some monotonicity. Okay, you can see that there is some monotonicity in increasing order of t. So in increasing order of t, there is some monotonicity, and from this only you realize that hey, binary search would work here, because whenever something is in sorted order and if you try to solve it using binary search, that is the most efficient, right? So what you can do, let's say you can do the usual binary search and you see how many total number of minutes maximum you can be using is that. So what is the upper limit, can you tell me? So see, by looking at the problem, you can just tell me that if batteries, if you sum over all the element in this battery array, okay, you take this battery array and sum over all these elements, let's say you get a sum, right? And you want to reduce, see, this is the maximum amount of battery usage possible. More than this, nothing is possible, right? And so what if you do sum by n? This will tell you integer division. I am talking about integer division, that is you do basically sum divided by n and then you take the floor value, okay. That is only integer division. I hope you know that. That happens by default in C++. So do not need to take floor on everything, anything separately. So what I am trying to say that this is the amount of time which is the upper limit, because more than this, you see, you cannot run, because see, of course you cannot run for t plus 1, because uh, I mean, this whole sum, if you are taking whole sum, you are already using all of the battery usage, okay, for n computers. And if you want to use for another unit of time, you need to use it for all the n computers, okay. So even if something is remaining, even if you are cropping out some values by doing seal, not seal, floor, okay, integer division, then also it is of no use. So this is the most upper limit which you can do, okay. So yeah, so binary search, when you are doing the binary search, you can keep your answer, let's say long, uh, you can keep left as, let's say 0 unit of time one is working, and rightmost constraint as something like sum by n, okay, sum by n plus 1, let's say something which is unachievable, this is too high. So your answer must lie between this L and R. So your answer will always lie between this L and R, and you can apply a binary search from L to R, and it is already proved, as I have already told you. This time, this L, what is this L? This is the total amount of time which the computer can run, and which is actually monotonous in nature, right? I have already told you. So that's why you can apply binary search. And so what you will write, I hope you already know how to do binary search on answer, right? If you have not, you can see my previous videos on this, and also Google that out, okay, how to do binary search on answer. What we generally use the template is, while L plus 1 less than R, I do M equal to L plus R by 2, and this is a binary search of type 11100. So what do I mean by this 111000? This is a binary search of type 111000. What does this mean? Okay, if you have not known, I will just tell you quickly. It tells you that there exists some point where you will not be able to run. So you see, you keep increasing your time, okay. So let's say this is time equal to 0. You can run your computer for 0 minutes always, okay, right? Always you can run all the computer for 0 minutes. You can always run your computer for 1 minute. So 1 denotes you can run the computer or not. So let's say you keep increasing the time, at some point for t max number of times you will be able to run your computer for t max minutes, okay. But when you go something like t max plus 1, you will not be able to run your computer. And yeah, that this is the monotonicity which I was talking about. If you are not able to run the computer for this many minutes, then you will not be able to run it in future also. And if you are able to run the computer for t max number of minutes, then definitely t max minus 1 number of minutes and all, you can run the computer, okay. I hope you do understand what I am trying to say. And you can write a function which will tell you whether the computer can run for m minutes, okay. So definitely you can go ahead and write a function if which will return a boolean value, right? So let's call this function is good. So is good tells me whether this m is good or not. So what does this I mean whether this m is good or not, whether you can run the computer, whether you can run n computers using these batteries for m units of time, okay. If it is true, then so let's say your L was here, right, and your R was over here, and your M is something pointing over here, then you move your L to M, you shift your L to M, and again redistribute your m to L plus R by 2. Okay, so that's what, if it is good, you do L equals to m, else you move your right pointer R equals to m, right? Else you can simply move your right pointer R equals to m, and at the end you can simply return L, right? And that will be your answer. That is everything, right? That is everything. So you just need to figure out how to write this is good function, and I guess that is also very simple. So let's try to code this out first, and we will then see. Okay, so I hope till now the explanation is clear and there is no difficulty or no confusion also. So I will try to write at first. See, there will be long multiple times, so I will just use hash define ll long. So as define ll long, okay, and batteries dot size m equals to, okay, and what else? You see, you need to define the maximum and the minimum range. So L and R you need to binary search over, and L you need to do 0, but this sum you need to calculate for R, right? So as to make it more efficient and nothing else, so L is 0 and R will be something which we will calculate. So let's calculate that first. So first have long, let's have it all long, okay. This sum will be nothing but 0 initially, but you can go through all the elements of batteries, okay. So you can go through this battery and do sum plus equals to x, okay, and after you have it, definitely you can do sum divided by n plus 1, okay. So that's what that is your right pointer and left pointer. You are telling that, basically you are trying to tell that for 0 minutes all the computers will definitely work, and for sum by n plus 1 number of minutes all the computers will definitely not work, okay, because yeah, more than this you cannot achieve. I just now told you, right? This is the upper limit. More than this means you cannot achieve, and something you cannot achieve is in R. So your answer must lie between L to R. Okay, so this much is very clear. And while L plus 1, and you know that this is a binary search of type 1 1 1 1 1 0 0 0 0. Okay, I had already explained you this logic behind this, how I'm trying to tell you. Okay, so these are just units of timestamp. As you increase t, there will come a point at which you will no longer be able to operate all the computers. So while L plus 1 is less than R, what you can do, if is good of m, so you will first calculate your mid value, okay, which will be simply L plus R by 2, okay. So you have it, and if this good m, n and batteries, if this is true, what will you do? You will do L equals to m. It means that if it is good, it means that if m, the m we calculated, that also lies in 1, then you shift your left pointer, otherwise shift your right pointer, okay. Otherwise you simply shift your right pointer, and at the end what you can do is simply return L, okay. So yeah, I hope this is very clear and not at all doubtful, because yeah, this concept is very simple. And this good only function which we need to write is boolean. It returns a boolean value, right? So is good, we have all long m with me, I have my integer n with me, I have this vector integer address batteries with me, okay. So yeah, I have these things. And what does this good function tells me? See, instead of m I will tell t, because that's the time, right? So whether I am able to operate n computers for t time, okay, whether I am able to operate n computers for t time, okay. So now you see what exactly will be this value, what exactly will be this value. Now if you try to see, this is actually simple, okay. See, you, no matter what is the distribution of batteries, no matter what is the distribution of battery, you will always be able to redistribute them and use them in the optimal possible way, okay. There is not much to think about that. You can take examples and see. But some batteries, let's say if the value is very high, those will be wasted. What do I mean by wasted? So see, I have already told you that you cannot run for more than t max number of times. So so t upper limit, what is the upper limit of t, that which I was telling? It is nothing but sum by n, okay. So you cannot run this for greater than sum by n number of times, okay. So if there exists, so if some values which is greater than this sum by n, it means that it has excess value and that will no longer be used. So when you are trying to check that whether these batteries will help to run n computers, so what is the thing which we are checking in this is good function, whether I will be able to operate n computers for t time, right? So whether I will able to operate n computers for t time. So you see, if one of these batteries contains a value, let's say this is a battery array, and some b of I contain a value which is greater than t. So can you tell that it has an excess value and some amount will be wasted. So what is the amount that will be wasted? B of I minus t, this amount will be wasted, okay. So when let's say you are calculating what is the total sum, that will be sum of all usages, okay, sum of all usages. So what will that be? You can just simply do sum plus equals to minimum of t comma batteries of I. What did I do just do here just now, okay. So if something is, I am trying to check whether n computers will work for t amount of time, okay, whether the computers will work for t amount of time, and if it is greater than t, then you clip the value at t. So this thing only tells you that you sum all batteries, okay, but if battery of I is greater than t, clip its value to t, okay. This is the thing which you are trying to do. And how will you tell me that whether it is possible or not? So now if this sum total all usage can run is greater than or equals to, can run n computers, okay, for t amount of time. So t amount of time into n computers. If this is true, then your Boolean function returns true, right? So yeah, I hope you do understand, okay, what I'm trying to do. That is the simple thing which we will do here, okay. So we have this again long sum, must not forget it, and what do you do for this? For auto x batteries, you add something to your sum. What is that? It is minimum of t comma x, right? And let's typecast this x to long because by auto it will have an integer type, okay, because vector is integer. So minimum value requires comparison of similar data types, so long and long. T is also long and x is also long here. So I add this value to my sum. So what is the sum again? What is the sum? It was like what is the usages, what is the time of usages of all these batteries. So now whether I am able to operate n computers for t times is given by whether this sum is greater than equals to n computers can run this n computers for t times. This is all you see, whether this is able to run. So return whether this, okay, return whether this, and if it is true, return true, if it is false, return false, and that is the Boolean data type which it will return. And you see, now our problem is just done, because this was very simple. This is a sort of template which we use every time for whenever we do binary search and answer. So the only thing which you are able which you need to think and do in this problem is just this part. I guess this is also not difficult at all. So yeah, I just don't know why they give this hard, but yeah, definitely I hope if you have done problems on binary search or answer, you must know this template beforehand, and you just need to write this is good function, okay. So yeah, that's all for the binary search method. Can we do it somewhere something without using this binary search? Okay, so when I ran it, it was giving 70 to 80% runtime bits also, but yeah, it varies a lot. Yeah, whatever be the case, let's try to see for the another approach, okay. So without doing any binary search, so can we still do it, okay. So there is a very neat trick for this. If you are able to come up with a binary search solution, it is well and good, you can go ahead, but let's try to explore the greedy approach also, okay. So there is an observation over here that, as I had told you, there are some batteries, and you cannot run, if it has n if you want to run n computers, you cannot run more than sum by n. This is the global minimum, okay. This is a global upper limit, okay. So you cannot run more than this. Now if some battery has a value, so okay, let's call this average, this is the average value, right? Now if some battery has an average value which is greater than this, if battery of I is having a value which is greater than this, so that battery will not cause any problem. We can keep it switched on always. Did you understand what I am trying to say? If something like this happens, we can keep this battery, keep BI switched on always, connected always connected, okay, because it is not causing any problem. So we can exclude our BI from our search, okay. So let's say we had M batteries initially, okay. N is the number of computers and M is the number of batteries, remember that. And let's say this particular B of I we saw, so let's say we will keep it in a sorted data structure like priority queue was set, okay. If we see that the first element or the greatest element is greater than this average value, then you exclude this, right? This will not be having any problem, and you just exclude this, and remaining batteries you just take those remaining batteries excluding that I, and try to check again that whether in the new average which you got, uh, is any element there which is greater than new average. If it is there, still you will be able to delete that element, okay. So what you can do, you can use a priority queue for this, right? Why priority queue? It is a max heap which will have the maximum element at the top. So there will be no hassle when you want to select B. See, if you want to select a BI which is greater than the average, you will always try to choose something which is the greatest value among all these BI, right? So priority queue will always give you the greatest value at hand, okay. It will this top element of the priority queue will always give you the greatest value which is there in the whole array. So that is very convenient, and we will keep subtracting. So we have a sum, we calculate average by sum divided by n. We will do n minus minus each time because one computer is one battery is decreasing, okay, or m whatever, and sum by n, the sum will be minus equals to this pq dot top, because this battery we just removed it, okay, we just removed it from our consideration. And yeah, for this. And if you see if each and every battery at one point, you see, I tell you that each and every battery or even maximum is less than or equals to average. So can you tell me how will that happen? It will only happen when all the elements are equal, right? So yeah, you can just check for that. So when Bmax is less than average, what less than or equals to average? So is it ever possible that Bmax is less than average? So if let's say the average of this whole array is 5. So some value will be more than 5, some value will be greater than 5, right? So all the values cannot be less than 5, right? So if I am checking for, see, if this value, this is not true, what I am trying to say is this, that if this thing is not true, you come at a point where you are done with excluding some element, and this point is not true anymore. What will be true then? This will be true. If that is not true, definitely this is true. Less than equal, if it is not greater than average, then it is less than equal to average, and each and every element are equal. At that point, it simply means that you can run all the computer for average number of times, and you can simply return the average, return that current average 5. That will be your answer. So you see, this will be a pretty small solution, and it will be very simple also. So just try to calculate this sum for now, and you are assigning a priority queue, right, which is a max heap by default, and it gives you the maximum element at the top. So batteries dot begin, it just takes all the elements from the battery and puts it into the priority queue, okay. You could have done you could have used a loop and pushed it one by one also, it would have taken the same time complexity, no problem about that. So yeah, we have the priority queue and the heap ready with us. While what we will do is that while this, what was our condition, b of I. So while pq dot top is greater than average, right? So what is the average? While pq dot top is greater than average was nothing but sum by this n, Okay, you might be thinking that this is integer division, but yeah, that is what, right? I hope you do understand. More than this we cannot take. So if a battery is there which is more than this value, we have no problem with that battery. Okay, that battery can be removed from our consideration. Okay, pq.top, and we can pop that element also. We can simply pop that element and decrease the n and go for the new average, right? We can simply go for the new average and see. You might be thinking that what if n goes less than 0 or something like that. That will never going to happen. Okay, so let me remove this line. So that will never happen. Why? Because at the last element, when the parity queue has only one element, then the sum is that element only, and n equals to 1. So that element will be equal to 1. So when priority queue has one element remaining, then obviously this loop will be broken out always. Okay, so you can always say that at the last element the loop will always be broken out, and you can simply do sum by n. That is all. That is all. You see, I hope this should also work. Let's try to see if it works, or we need to do some adjustments. You see, this is also working. If you try to submit this, I hope this will be a more good approach. Yeah, this might be a little difficult to come out with. That binary search approach is very trivial than this. Yeah, but this also works. This, although this uses a priority queue, but yeah, the code is very short, and you see it's less than 10 lines of code. So yeah, that's all for this video. I hope both methods were very clear to you and you were able to learn something new. Definitely like this video and comment if you definitely learned something new from this. Okay, so yeah, that's all for this video. I will meet you in the next video. Till then, thanks a lot.